Welcome to Implicit Differentiation. So just a reminder that there is going to be an exit ticket at the end of the lesson. So plan on 5 to 10 minutes to answer it, but it's just a completion grade. It's not going to be graded based on right or wrong. Okay, with that said, let's get started. So let's first consider this problem. What if I asked you to find the derivative of xy equals 1, the derivative of y with respect to x? So the first thing we need to do is we need to take this thing and solve for y. And that's easy to do, just divide both sides by x. And then finding the derivative, we can just rewrite it as a power and easily use the power rule. Multiply by the exponent, subtract 1 from the exponent. And it's nice to rewrite it like this. If it was given in this form, I mean, it was given here. But anyway, you can leave it either way. But there's your answer. Straightforward, easy peasy. But what if I asked you to do the same thing for this problem? Now we have a problem. Because what are we going to do? We can't solve this thing for y. How do we do it? I'm sure there is a way to solve it for y, but I don't know what it is myself. But the good news is we don't have to solve for y. And that's what implicit differentiation is about. So implicit differentiation we use to find derivatives when we can't solve for the variable you're finding the derivative of. We're finding the derivative of y with respect to x. We can't solve for y. We can use implicit differentiation. So let's just remind ourselves, first of all, what dy dx means. So dy dx, this is like literally it means the derivative of y with respect to x. When we say the derivative of y, that means y is the function. And when we say with respect to x, that means that x is the variable of the function. Or we can also think of it as the variable of differentiation. So we want to ideally be able to solve for y in terms of x. But what if we can't do that? And that's implicit differentiation. So let's kind of take a step back and look at some simpler problems. So if I want to take the derivative with respect to x, so x is my variable, and this is saying x is the variable in my problem, it's good to go. The variables agree, so we just differentiate like normal. And we can use power rule for this one. Same thing with this one. Differentiate with respect to x. So we're differentiating with respect to x. X happens to be the variable of the problem. The variables agree. You just take the derivative like normal. And in this case, remember, we got to use chain rule so that's why that 2 is out there. Now, when you have a problem like this, where the variables don't agree, so we're differentiating with respect to x, but y is the variable. So what do we do? Remember, y is the function of x. So there actually is a composition of functions here. It just doesn't look like it. But y is the inside function inside the cubed. And that's what it's saying over here in purple. I mean, you can think of that as like g of x inside f of x. So y would be like g of x, the inside function. F of x would be the cubed function, the outside function. So when the variables don't agree, you got to use chain rule. So how do we do that? Well, just differentiate like normal, first of all. So we're just going to use the power rule like normal. But then we have this inside function of y, so we multiply by its derivative, dy dx. And that's it. The reasoning actually kind of makes it more complicated, but really, whenever the variables don't agree like this, start off by differentiating like normal, but then multiply by dy dx. And we're doing that because of the chain rule. So what does it mean? When the variables agree, like here, you differentiate like normal. When the variables don't agree, differentiate like normal, but then use the chain rule and multiply by dy dx. Variables agree, differentiate like normal. Variables don't agree, differentiate like normal, but then multiply by dy dx. That's the bottom line. And that's implicit differentiation. So let's go back to that problem I gave you earlier. So it was this one. What if we want to find the derivative of this? Well, we're going to differentiate term by term. So this first term, if we're differentiating with respect to x, then this first one, x, the variables agree, differentiate like normal. The second term, x, y, the variables don't agree, differentiate like normal, but then multiply by dy dx, multiply by the inside function. Third term, again, the variables don't match. So differentiate like normal, but then use the chain rule, multiply by dy dx. My cat says hi, by the way. That's Crash. He's probably going to meow throughout all of this. And then 2 is a constant, a derivative of a constant is 0. Sorry about that. All right. So we have this. I'm sorry, that was very distracting. So again, variables agree, differentiate like normal. Variables don't agree, differentiate like normal times dy dx. Variables don't agree, make sure you multiply by dy dx. Now, we have to solve for dy dx, so the easiest thing is just isolate the terms with dy dx. So that's these two terms. Move this term over to the other side. Then you can factor out the dy dx and then divide. And then in this particular problem, we had 1, 2, 3 terms in the final answer, and 2 of them are negative. So more than half the terms are negative. It's nice. It's optional. It's not required, but it is preferred to minimize the negatives. Just multiply top and bottom by -1, and then we can. So when you have a fraction and you can multiply, because remember this is just multiplying by a form of 1. So when you can minimize the negatives, it's a nice thing to be able to do. All right. So once you think you got the hang of that, try these two. And I actually don't have these worked out for you. So you're on your own. I've given you the answer, but try working out these two problems. And if you have trouble getting the answer, ask your table mates. They're working on the same problems. There's the peer tutor. Remember, first period we got Avanish, second period we got Aditi, and third period we got Liam. You can ask them for help too. But I'm purposely leaving out the solutions because I want you to try these on your own. But I am giving you the answers so you can check your work. So try these and pause the video. And then when you're ready, you can go ahead and resume it. And because it's really just, dealing with some trickier problems. But just some more examples. Okay, I'm assuming you paused the video. So now let's go ahead and try to find this one. Now, I've given you a hint here. Using the product rule, you might have to, sometimes you need to. So try this one also on your own. I do have the worked out solution coming up, but seriously, try to work it out yourself first. And again, I've given you the answer so you know what you're shooting for. But there might be a product rule hidden in this problem. Nudge, nudge, wink, wink. So give it a go. And when you're ready, unpause the video. All right. So I'm going to just quickly walk through the solution to this one. So this middle term is a product of two functions. We have sine x, cosine y. So the biggest mistake students make with implicit differentiation, actually there's two of them. One mistake is they forget about product rule or quotient rule. It's something about product rule that they forget. The other thing is, don't forget, anytime you take the derivative of a constant, it's 0, not itself. Okay, so anyway, take the derivative of the first term. It is not a product of two functions of a variable, so we don't have to worry about that. Variables agree, x and x, so you differentiate like normal. The second term is a product. I'm going to treat the 4 sine x like my first factor and cosine y like my second factor. So we have u dv plus v du. Again, the variables match. Well, actually, we're not taking the derivative. So u just writes down. Variables don't match, so I have dy dx. And then plus v, so I just write it down. And then times the derivative of u. The variables match, so I don't have a dy dx here. Derivative of this term, Variables don't match, x and y, so I do have to multiply by that dy dx. Derivative of 7 is 0. And then I just kind of cleaned it up a little bit. There wasn't much to clean up, but I did go ahead and positive times a negative is a negative, and I put this 4 in front. But now I collect the terms with dy dx on one side, the terms without a dy dx on the other, and factor out my dy dx, divide, and in this case, every single term wound up with a negative. So I did minimize the negatives by multiplying top and bottom by a -1 and got this. All right. Now, there is one last problem for you to try on your own. So see how you do with this one. You can practice that. Maybe there's a product rule in there. Maybe there isn't. Here is the answer. And then when you believe you are ready, you can go ahead and do the exit ticket. The exit ticket actually has a couple of like math problems to see if you got the lesson. There's some simple ones though, nothing too time consuming. And then there's also just some questions on how the videos have gone. You'll see when you read it. So anyway, that's it, and hopefully I will see you guys next week. Let's keep our fingers crossed. I'm still a little sick, having trouble kicking the fever, but hopefully I will be back. All right, I will see you guys later. Bye.